Now that we've seen what kind of problems we should be providing for our learners, let's turn to the learners themselves and examine the kinds of strategies that they use when engaged in problem solving. We're still working with the second standard in the operations and algebraic thinking domain, which begins solve, addition, and subtraction word problems. But there are different levels of solve. Do children need to be able to solve it by acting it out? Are they allowed to use counters? Are they supposed to count on? Should they be using an arithmetic strategy? During the first few years of school, they will go through a developmental sequence and their solution methods that involves all of those components. So we're going to take a look at what kindergarten problem solving needs to look like, as well as foreshadow the levels to come, since you will likely have some learners who are ready to advance. Then the second part of this standard talks about adding and subtracting within 10, which is certainly required for solving word problems, but it can also include a broader set of circumstances. So the solution methods that we discuss in this lesson can be used for word problems or more decontextualized addition and subtraction, for example, 3 plus 4, rather than being dressed up in words. There are a few basic skills that your children need in order to be successful in problem solving. So you will want to make progress in these areas before having students solve problems individually. For this reason, problem solving will likely play a bigger role in your curriculum during the second half of the year, at least individual problem solving, where individuals are expected to solve a problem. Collaborative problem solving can occur much earlier. The standard only specifies that they need to work within 10, so they should know the number word list beyond that amount, but it isn't necessary to wait until they can count to 100 before beginning to problem solve. They do need to be able to count meaningfully rather than just random pointing with a number word sequence that isn't in synchrony with the pointing. These are all topics that are addressed in the counting and cardinality domain. Finally, you see the ability to act out a situation. Children actually benefit initially by seeing problems acted out in more collaborative problem-solving experiences, which gives them a sense of how to go about modeling experiences for themselves. Nevertheless, you will almost certainly run into children who seem initially incapable of acting out situations, and we'll discuss that in the next lesson. Children's work with word problems and mathematical situations, as opposed just to working with number sentences, for example, is particularly helpful to children's long-term mathematical development because fairly early in elementary school, they need to learn how to decontextualize word problems, being able to pull out not just the numbers, but the relationship that's embedded in the words, and that is very difficult. So they really need this acting out experience that they're going to have in kindergarten to build the foundation for how quantities are related to one another in a whole variety of situations. If children do not develop this capacity to begin to interpret numeric relationships that are embedded in words, if they don't develop that tendency, they have the likelihood of some significant struggles in mathematics, either now or in the future. Therefore, it is important that children engage in problem solving in ways that connect deeply to their sense-making, not just of the numbers themselves, but of how the words and the situation guide us in perceiving a particular relationship between the numbers. When children act out math problems in kindergarten, they're doing the hard work of laying that foundation, which will allow them to mathematize problems. To guide our discussion of kindergarten problem solving, I'm looking at the Common Core progressions and other documents that were important to Common Core authors in the writing of the standards. The authors have expressly stated that one of the particularly important documents that guided their work was Mathematics Learning in Early Childhood by Cross, Woods, and Schweingruber. This document is available for free download, and I've included the link for that in the teaching resources for this lesson. Now, the statements on this slide all originate from that report, and they're all related specifically to kindergarten teaching and learning. The first bullet point involves conceptual subitizing and cardinal counting, which we discussed in the Part A module that dealt with counting and cardinality. We will only briefly have time to examine the role that those two components play in problem solving, which we'll do in a minute. The other thing you see here is the importance that is placed on acting out problems as a solution strategy, using concrete tools such as fingers, objects, and drawing. So this is not a time where we remove those tools. They need to be using those tools. Now, cardinality, we're going to talk about the right side of the screen first. Cardinality is necessary to count meaningfully, as opposed to just stating a number sequence by rote. For a problem involving a set of 4 being joined with a set of 3, I could build a set of 4 blue counters, then a set of 3 blue counters, then I could shove all those counters together into one group, start counting them again, starting with 1. And that would be direct modeling, in this case using generic counters. Some children can easily pretend that a counter stands for something else, like a car, whereas other people prefer to draw pictures of the actual items or use a realistic manipulative, something that looks like the real thing. Toy cars if they have a problem about cars. We're going to talk a little bit about those 2 levels when we discuss how to work with children in the early stages when they are having some difficulties. But for children who would have that issue, they would prefer to work with something that looked like rabbits if they had a problem about rabbits, for example. Conceptual subitizing, which is over on the left side of the screen, was a previous topic in the counting and cardinality strand. I don't have time to discuss it in detail here, but basically it involves seeing the value of 2 subsets without even needing to count them, being able to see the 3 and see the 4, and then being able to use a known relationship in order to construct a strategy. So here, for example, you can easily see at a glance that it's 4. You don't have to go 1, 2, 3, 4. Not all children can do that, but many children can subitize that that's 4 and just see it without counting, and also the same for 3. And then in the tens frame structure allows children to perhaps easily be able to detect a pattern, which is, oh, that looks like the 6 on a dice, and 1 more to get 7. So that's called conceptual subitizing, and the Common Core authors describe the importance of conceptual subitizing in fostering advanced arithmetic strategies. So if it's unfamiliar to you, I would suggest that you learn more about it, because the Common Core progressions expressly states that conceptual subitizing is an important skill to build in kindergarten. Kindergarten children can represent a pretty wide variety of background knowledge, but you will typically find that their problem solving uses level 1 methods. Level 1 is basically direct modeling. It has some distinctive features. All of the physical quantities in the problem are represented in the solution method. And also the story is extremely important. Children use the action and the relationships in the word problem exactly. They will model first the first thing that happened, and they'll model it first, and then they'll act out the next thing that happened in the story. And so they kind of follow the story to walk them through a solution strategy. And the other feature going back is this: all physical quantities are explicitly represented. So unlike counting on, which is a horizon concept where you might be able to say 3, 4, 5, 6, 7, you're not going to be able to do that here because the 3 has to be represented as well. There are several different types of level 1 solution methods that actually fit the criteria that we just talked about, but there's only 2 that we're going to really talk about now, because these are the 2 that would be used for the kinds of problems that are designated for kindergarten, those 4 problem types we discussed in the last lesson. Count all is used with problem types where the total is unknown, but you know both of the parts. And takeaway tends to be used with problems where you know the total. So these are the 2 types of approaches, and we're going to take a look at them each now. The count all approach involves building the first set by counting out the objects, building the second set by counting out the objects, then going back and counting everything all over again, starting from 1. You can see this in 2 examples here. The Common Core authors provide the example at the top of this slide in their progressions document. And then the example at the right is actual work from a kindergarten child. Now this particular problem that you see her working with has 3 addends, and the sum exceeds 10. So this is above and beyond the Common Core requirement, but it could be used to extend some of your learners. And you see that she has created each of the sets separately and then counted all of them to get to her answer of 14. The takeaway method works well with the take from and the take apart contexts, although it actually doesn't work so well with some of the other types of subtraction problems that children will be exposed to in first grade, such as compare problems. The strategy involves building the total and then partitioning off the known part to figure out the unknown part. In this example, you can see how this looks. The child has a strategy of crossing out the balloons that burst. That was the known part, and although the assignment didn't require it, her teacher had been modeling how to write number sentences for subtraction, and so children were encouraged to try it for themselves if they understood what to do. So she actually went ahead and attempted to write a number sentence here. Once she was able to cross out the known part, the 3 that burst, she could figure out how many were left and relate the total, the part that burst, the part that didn't burst, and she was able to see those relationships, and in this case see them well enough to even talk about what that would look like in a number sentence. Now, the other type of problem that you could use a takeaway method for that we discussed was the both add-ins unknown kind of problem. We're actually going to discuss that problem type much more closely when we discuss standard 3, since it fits really nicely with decomposing. As you watch children problem solve, you will be particularly drawn to elements that are easily seen. For example, you might notice that they're using their fingers or they have a drawing. I encourage you to consciously attend to the strategies that children are using, and that isn't the same thing as the tools. Strategies are not seen because they're mental. A child can use fingers as a tool for direct modeling or as a tool for counting on. And counting on is significantly more advanced cognitively. So knowing what tool a child is using really doesn't help me gain any insight into how a child is thinking. But watching how they use the tool can sometimes give insight into how the child is thinking. Also, as they use the tools, ask your learners what they represent. You can say, I see you have 3 counters right here. What does that mean in the problem? Are these 3 boys or 3 girls? So you're constantly helping them make connections between the tools they're using to represent the problem and the meaning of the problem. So let's take a quick look at what this means, the idea that tools can differ, but the strategy might perhaps be the same, or the tool might be the same and the strategy might be different. As an example, I want you to imagine a small group of kindergartners who are all solving the following problem. 5 zebrafish were swimming near the coral reef. 6 clownfish joined them. Now how many fish are swimming near the coral reef? You see here some anecdotal records about what each child did to solve the problem. Notice how dramatically their tools differed, but the way in which they used the tool involved physically representing the group of 5, physically representing the group of 6, then counting them all over starting with 1. Therefore, despite the different appearances of their work, what it looked like in practice, the underlying cognitive strategy they were all using was the same. Now we'll revisit this chart next week, only next week we're going to be talking about representation, so we're going to take an interesting look at some of the representations these children chose to use and what we can learn about them from that. As children engage in early problem-solving experiences, there's a fundamental understanding of mathematics that we want them to develop. And that big idea of mathematics is that you must add like with like. For example, if you know that you have 5 planets and 2 pencils, you really don't have 7 of anything, because planets and pencils are just simply too disparate to be linked together in a larger group. As you add 2 groups, you may have to rename them, however. So in the case of planets and pencils, how would we rename them? They're so disparate, we wouldn't really have a good tool. I mean, we'd have to go with something really generic. Stuff in the universe. I don't know what we would do there. It'd be too broad. So if you add 2 groups, you may have to rename them, and this example illustrates this. We have 5 circles and 4 squares, resulting in 9 somethings. 9 what? Well, we have to find something that is true about both of these, so we could call them shapes. 5 circles plus 4 squares equals 9 shapes. But children need to know that when you add things, that they have to be similar in some way so that when you end up with your total group, you can call it something. And so that's a big idea that they are very unlikely to get unless you're actively fostering that concept. And it's such a foundational idea, it's going to be critical as children move into first grade, for example, because they need to know that you add tens with tens and you add ones with ones. And if you have 2 tens and 3 ones, you don't have 5 of anything. You have 2 tens and 3 ones, or 23. All right, so this idea of adding like with like provides a really foundational concept for subsequent work in the number strand. Although the goal for all children is that they can successfully direct model the 4 designated problem types with ease for all number sets within 10 by the end of kindergarten, you will almost certainly have some learners who move beyond this goal. So we're going to take a look at the next levels of solution methods outlined in the Common Core progressions. Level 2 methods involve counting on, and level 3 methods involve converting the problem into an easier problem to solve. Here you see the 2 levels contrasted using 5 plus 4 as an example. Now this expression, 5 plus 4, could be given as shown, or it could be embedded in some kind of a problem, word problem. In level 2, a child abstracts one of the values and moves forward. In this case, they would likely abstract 5 for 2 reasons. Both that it's first, because some children always do it for the first and move forward, and then when they get more advanced, they choose the larger value. In this case, the first and the larger are the same. So I think it likely that they would count on from 5 in this example. Now, abstracting the 5 and moving forward 6, 7, 8, 9 is a lot more difficult than you might expect. There's quite a bit of abstraction that has to occur in that process. Level 3 methods are even more advanced. They involve converting the problem to an easier one by using a familiar, well-known fact. Here you see 2 examples. The top one uses a doubles plus 1 strategy. So the child perceives a hidden double in 5 plus 4 and recognizes that it's almost like 4 plus 4, except there's one more. So he knows that 4 plus 4 is 8, so therefore 5 plus 4 must be 9. The bottom strategy might be considered a sum of 10 minus 1 strategy. Here a child recognizes immediately that 5 and 5 is a combination of 10, and that 5 and 4 is 1 less, so it must be 9. And I included some visual images here to help you see how visual images can help to facilitate this kind of thinking. Although you're not charged with facilitating level 3 strategies in kindergarten, the work you do with visual models paves the way for that future thinking. Next, we'll look at specific things that need to happen in kindergarten that directly influence the development of these strategies, if not in kindergarten, then in first grade. These strategies, both level 2 and level 3, are designated for first grade, but are entirely dependent on competencies that the Common Core authors placed at the kindergarten level. Notice that the prerequisites for level 2 rely heavily on the kindergarten work done in the counting and cardinality domain. Children need to have the number word list learned well beyond the numbers where they will first be learning to count on. They also need to understand the idea that the quantity of 5, for example, has an embedded quantity of 4 and 1 more in it. Now this idea is called nested numbers. We talked about it in Part A, and it should support children in being able to move forward 1 and back 1 to find 1 more and 1 less. Children also need to be able to count forward starting from a given number and stopping at a target number. Oftentimes you will find a child who can count on, but who just keeps counting and they don't stop at the target number. That poses difficulties before a child can count on in an actual counting situation. Now, while these are prerequisite skills, there are also additional skills that need to be developed in order to effectively count on. For example, there are considerably higher demands on keeping track of one's counting and interpreting an answer from one's system for keeping track. These levels of abstraction will have to be overcome, but they can't be overcome until these foundational concepts have already been developed. Level 3 methods also rely heavily on kindergarten competencies, and these competencies were expressly placed in kindergarten so that the first graders could make this transition. The Common Core authors were extremely intentional about that. It's just ridiculous to have students attempting level 3 strategies until they have already had extensive opportunities to decompose numbers up to 10 into 2 addends. And in addition, their work with understanding place value elements of teen numbers is critical to level 3 because a lot of those strategies involve making a 10. Level 3 methods involve using this knowledge in a coordinated way. So you have to already have the knowledge really solid in order to be able to make decisions about what you're going to do first and what kind of approach you could use second. To coordinate it into a complex sequence requires a lot of cognitive load. So the actual knowledge base that's listed here, these competencies, have to be really solid. Several things that we've talked about refer to the counting and cardinality domain, and if you've taken the Part A module, you may have already had that. If you haven't, I encourage you to read the progressions document, which is listed here. Also, the Cross, Woods, and Schweingruber document. Both of those are available for download.